Welcome. This is Vision Mathematics. My name is Thomas Swanda, and I'm going to take you through the lesson on this video. Lesson number 7, Trigonometric Identities. In this lesson, we will be dealing with how to prove trigonometric identities. In particular, we will be looking at proofs that require the use of compound angle formulae and or double angle formulae. Example number 1. Prove that 1 minus cos 2x over 1 plus cos 2x equal to tan squared x. Obviously, the left-hand side is more complex, so we'll start from the left-hand side. We observe that both numerator and denominator have cos 2x, and it is the one which has 3 versions of double angle formula. So we have to choose carefully from among those 3. We'll be guided by the result which we want to achieve, tan squared x, remembering that tan x is equal to sin x over cos x. That suggests that in the numerator we should choose the one which involves sine, and in the denominator we choose the one which involves cosine. So left hand side equal to 1 minus, and replacing cos 2x with 1 minus 2 sin squared x. Refer closely to your information sheet. Denominator 1 plus, we replace cos 2x with 2 cos squared x minus 1. And removing the brackets in the numerator, that's minus 1 times 1 gives us minus 1 here. Minus 1 times minus 2 sin squared x gives plus 2 sin squared x. Denominator is 1 minus 1, which gives 0. We are left with 2 cos squared x. Simplifying further, the numerator 1 minus 1 is 0. We are left with 2 sin squared x over 2 cos squared x. Now these 2's will cancel. Then we are left with sin squared x over cos squared x, which is equal to tan squared x, which is equal to the right hand side. Example number 2. Prove that cos x minus sin x over cos x plus sin x equal to cos 2x all over 1 plus sin 2x. Now, looking closely at the identity, on the left hand side, we observe that both numerator and denominator are actually in their simplest form. It's difficult to see how you can start. Whereas on the right hand side, you have double angles, so we can make substitutions. Therefore, we choose to start from the right hand side. So the right hand side, cos 2x, remember it is the one which has 3 alternatives to choose from. We are guided by cos x sin x here, so we select the one which has both cosine and sine, which is cos squared x minus sin squared x. In the denominator there is only one form of the formula for sin 2x, which is 2 sin x cos x. Now, guided again by the numerator here, it suggests that we must factorize this. This is a difference of 2 squares. So factorizing, we have cos x minus sin x into cos x plus sin x. And this is actually what is here. It means that we must have cos x plus sin x in the denominator to cancel with this one. And we need to also remain with the cos x plus sin x, which should produce this thing. So it suggests that our denominator should actually be cos x plus sin x multiplied by cos x plus sin x, which is actually a square of a binomial. Now, comparing that with the square of a binomial, the middle term is 2ab, and looking here, this looks like that, because if we take sin x as a and cos x as b, this is 2ab. So we need only create a squared and b squared, which in our case should be sin squared and b squared. Fortunately, we have the identity which gives those things. and it is cos squared x plus sine squared x equal to 1. So all we need to do is replace this 1 with that. So that's what we are going to do here, replacing 1 with cos squared x plus sine squared x. Now plus 2 sine x cos x. Then rearranging so that it looks much more familiar, just taking sine squared x to the right so that we have that in the middle. We have cos squared x plus 2 sine x cos x plus sine squared x here, equal to, then we factorize that. This is actually the square of a binomial. It is the square of cos x plus sine x. So cos x plus sine x. Now this cancels with that, and this is the result that we were looking for. So that's equal to cos x minus sine x over cos x plus sine x, which is equal to the left hand side. Example number 3. Prove that sine 2x over sine x minus cos 2x over cos x equal to 1 over cos x. Clearly the right hand side is simple. We choose to start from the left hand side, which is more complex. The left hand side are two fractions, so we put them under one common denominator. We can use the shortcut of cross multiplication. The common denominator will be sine x multiplied by cos x. That's our common denominator. The numerators are found by cross multiplication. Sine 2x multiplied by cos 2x. And cos 2x multiplied by sine x. Now, this result looks very familiar. Sine 2x cos x. Cos 2x sine x is the pattern sine cos cos sine, which reminds us of the compound angle formula for sine, which is this. That's sine A cos B cos A sine B. Working from the right to the left, it simplifies to sine A minus B. So applying that here, it will simplify to sine 2x minus x. That's the angles we have, 2x x, 2x x. So it simplifies to sine 2x minus x all over sine x cos x. Now these are like terms and they can be simplified. So that's 2x minus x is x. So that's sine x over sine x cos x. The sine x is cancel. Sine x into sine x 1. Sine x into sine x 1. And then we finally remain with 1 over cos x, which is equal to the right hand side. Example number 4. Prove that 2 sine 5x cos 4x minus sine 9x equal to sine x. Now this looks quite unfamiliar, but looking closely at the numbers, we can see that 9x is equal to 5x plus 4x. It's a very important skill to be able to see relationships between numbers. This is where I advise my learners that they shouldn't rely too much on their calculators, to the extent that even 3 times 4 you pick up your calculator, because that way you won't be able to see relationships between numbers like this. So here, this suggests that if we rewrite 9x as 5x plus 4x, we might be able to expand this using the compound angle formula, and we will produce something like this. Let's do that and then see how we can proceed. The left hand side, first copying the first term as it is, 2 sine 5x cos 4x minus sine, then rewriting 9x as 5x plus 4x. The next thing, we expand this using the compound angle formula for sine. It says sine A plus B is equal to sine A cos B plus cos A sine B. Now comparing this with that, that means our 5x is the A, 4x is B. Then expanding that using that formula, we have 2 sine 5x cos 4x
minus, put that in brackets, sine 5x cos 4x plus cos 5x sine 4x. Then removing the brackets, assuming coefficient here is 1, we have 2 sine 5x cos 4x, then minus 1 times sine 5x cos 4x will be minus sine 5x cos 4x. Then minus 1 multiplied by plus cos 5x sine 4x gives us minus cos 5x sine 4x. Then looking closely at the expression, we see that the first two terms are like terms. They are both terms in sine 5x cos 4x, so they can be added. That's simplifying that, we obtain 2 minus 1 here is 1, so it's sine 5x cos 4x minus cos 5x sine 4x. Now this looks quite familiar. It's like sine A cos B minus cos A sine B, which suggests compound angle formula for sine. And this is the formula. It says sine A minus B is equal to sine A cos B minus cos A sine B. And what we have here is the right hand side. So we have to work backwards, which says we subtract the angles. So this is equal to sine 5x minus 4x. And subtracting here, we obtain the right hand side, which is sine x.
Here are the suggested solutions. Number 1, we are required to prove that cos to the power of 4x minus sine to the power of 4x is equal to cos 2x. Now here the left hand side looks much more complex than the right hand side, so we choose to start from the left hand side. Now observing that this is a difference of two squares, because this is cos squared squared, we factorize that using factors of difference of two squares. That's cos squared x minus sine squared x into cos squared x plus sine squared x. Now this is the right hand side of one of the double angle formula for cosine, and this is 1. So making substitutions, that is cos 2x multiplied by 1, which simplifies to cos 2x, which is equal to the right hand side. Number 2, to prove sin x plus sin 2x all over 1 plus cos x plus cos 2x equal to tan x. Clearly we have to start from the left hand side, since the right hand side is very simple. That's left hand side. We have a double angle here for sin 2x, and there is only one way of replacing that. So that's sin x plus 2 sin x cos x. In the denominator we have cos 2x, which has 3 alternatives. We are guided by tan x, which is equal to sin x over cos x. So it will be best to avoid sin x in the denominator. So we choose the one which has cos x only. So that's 1 plus cos x, then replacing cos 2x with the double angle formula, 2 cos squared x minus 1. Now 1 minus 1 is 0. So in the denominator we will remain with cos x plus 2 cos squared x. In the numerator we observe a common factor sin x, and factoring that out we have sin x into 1 plus 2 cos x. In the denominator we also observe that cos x is a common factor. So we go on to factor out cos x. We remain with 1 plus 2 cos x, and this cancels with that, giving us sin x over cos x, and this is equal to tan x, which is equal to the right hand side. Question number 3. We are required to prove that cos x over sin x equal to sin 2x minus cos x all over 1 minus cos 2x minus sin x. Now looking at the identity, we see that the right hand side is the one which is more complex. The left hand side is in its simplest form. You can't see how to start. So we choose to start from the right hand side. So right hand side equal to, replacing sin 2x with its double angle formula, which is 2 sin x cos x, then minus cos x, all over 1 minus cos 2x. Now this is the one which has 3 options, and we have to choose carefully. We are guided by the denominator here, sin x, so we choose the one which has sin x. So that will be 1 minus, replacing cos 2x with 1 minus 2 sin squared x, then minus sin x. In the numerator, cos x is common, so we factor that out. That will be cos into 2 sin x minus 1. In the denominator, clearing the brackets here, that will be 1 minus 1, then this negative and that negative will make a positive. So that's plus 2 sin squared x minus sin x. Then 1 minus 1 is 0. So we have cos x into 2 sin x minus 1 all over 2 sin squared x minus sin x. Now sin x is a common factor here, then we can factor that out. We now have cos x into 2 sin x minus 1 all over sin x into 2 sin x minus 1. Then 2 sin x minus 1 cancels with 2 sin x minus 1. And we remain with the required result, cos x over sin x, which is equal to the left hand side. Number 4, to prove sin x plus y over cos x cos y equal to tan x plus tan y. These all are in their simplest form. Cos x cos y also in its simplest form. This can be expanded using compound angle formula, so we start from there. That's left hand side, sin x cos y plus cos x sin y. Now at this point, being guided by the fact that tan x and tan y are separate, being added together, we can split here the numerator. Now, in order to understand how this works, perhaps let me take you back to grade 8. If you were required to add these two fractions, they have the same denominator 8. 1 over 8 plus 3 over 8. You simply add the numerators over the common denominator. Now, looking at the same from the right hand side, if you have 1 plus 3 over 8, this is equal to 1 over 8 plus 3 over 8. In other words, you can separate the 1 and the 3, putting each of them over 8. So that's exactly what we are going to do here, which is called splitting the numerator. We will put this over that, plus this over that. So that is equal to sin x cos y over cos x cos y, plus cos x sin y over cos x cos y. And looking closely at the two fractions, we observe some common factors. Here, cos y is common, so these will cancel. Cos x is common, they will cancel. So you remain with sin x over cos x plus sin y over cos y. Clearly, this is equal to tan x, and this one is equal to tan y, and that is equal to the right hand side.
Let us have an alternative approach to question number 4. It asked us to prove that sin x plus y over cos x cos y equal to tan x plus tan y. Now, if we remember the identity that tan x is equal to sin x over cos x, we will be able to start from the right hand side. The right hand side is equal to replacing tan x with sin x over cos x plus, and replacing tan y with sin y over cos y. Then the next step is to express these two fractions as a single fraction with a common denominator. Now, since cos x and cos y do not have a common factor other than 1, then their lowest common multiple is their product, which happens to be our lowest common denominator. That's cos x cos y. Then we find the numerators by the short method of cross multiplication. So that's cos y times sin x gives us sin x cos y. Then cos y times plus sin y gives us plus cos x sin y. And this is the right hand side of one of the compound angle formula for sine, which is the addition one. And it's going to give us exactly that. So that is equal to sin x plus y over cos x cos y, which is equal to the left hand side.
Number 5, to prove cos 60 degrees plus x cos 60 degrees minus x equal to 1/4 minus sine squared x. Now clearly this shows us that we must expand using the compound angle formula. So expanding the left hand side, this expands to cos 60 degrees cos x minus sine 60 degrees sine x. And this one expands to cos 60 degrees cos x plus sine 60 degrees sine x. Now 60 degrees is a special angle, so we substitute for the trig ratios of the special angle. That's cos 60 degrees is half, then cos x. Sine 60 degrees is the square root of 3 over 2 sine x. And cos 60 degrees half, sine 60 degrees root 3 over 2. Now if we look at this carefully, it will save us a lot of problems trying to expand that. We observe that this and this is exactly the same, and this and that exactly the same, minus here plus here. These are factors of a difference of 2 squares, so we can use that to expand that. In other words, the answer is this squared minus this squared. So squaring half cos x, the square of half is 1 over 4. then cos squared x. And here the square root of 3 is 3, the square of 2 is 4, then sine squared x. And now, observing that the result we want to produce does not have cos x, it suggests that we must eliminate cos x. We must substitute for cos x. So that's 1/4 into 1 minus sine squared x. I hope you remember the identity. It comes from cos squared x plus sine squared x equal to 1. When you now make cos squared x the subject, it gives you cos squared x equal to 1 minus sine squared x. Then minus 3/4 sine squared x. And removing the bracket, that's minus 1/4 times 1 gives, 1/4 times 1 gives us 1/4. Then 1/4 times minus sine squared x is minus 1/4 sine squared x minus 3/4 sine squared x. And these are like terms. They are terms in sine squared x, and they have a common denominator, so you can add the numerators. So that's our 1/4 here, and here is minus 1 minus 3, which gives us minus 4. Minus 4 over 4 is minus 1 here. So that's 1/4 minus sine squared x, which is equal to the right hand side. We have now come to the end of this lesson. Thank you for watching, and goodbye.